Okay, we're going to look at how it is we can analyze limits analytically, that is, computationally. And the first method we have for analyzing limits is what we call direct substitution. Now, as we go through the next couple of class periods, we're going to continue to add to that list. But for today, we're just going to deal with the direct substitution. And in direct substitution, you simply do exactly what it says. You substitute indirectly the value for x that you were given. So let's go through some examples here. In example 1, we are going to calculate the limit as x approaches 2 of the function 10 minus 3x. Remember, for our notation, that's what this says. We've got the limit as x approaches 2 of, and that's the function there. We're going to attempt to do a direct substitution. And it's not necessary that you do these steps, but if you can go straight to the answer, that's fine. I'm going to show you the steps in between. Every time I continue on into another step with the same problem, I'm going to use the equal sign to indicate that I am still working on the same problem, but I'm moving down a line. In direct substitution, we're going to take this value here, and we're going to go into our function, and everywhere there is an x, we're going to replace it with a 2. So this becomes 10 minus 3 times 2, or 10 minus 6, which is 4. Notice that the limit notation goes away as soon as I make that direct substitution. And it really is as simple as that. Let's go ahead and try some more examples here. Okay, so let's try another one here. And number 2, let's go ahead for number 2 and look at the limit as x approaches negative 1 of the function negative x plus 3 quantity squared. Now, I'm going to go ahead and start putting in this value, again, using a direct substitution. That means that anywhere inside of this function I see an x, I'm going to replace it with a negative 1. So this is going to give me, look at my formula here, I have minus, and then I have x, which will be a negative 1 plus 3. And we can actually change those parentheses to brackets. They mean the same thing, but it just makes it a little bit easier to see. Before we can apply an exponent, we've got to get it down to a single number. Minus a negative 1 makes it a positive 1, and positive 1 plus 3 is going to be 4, and 4 squared is going to give us 16. Let's continue on with some more examples here. For number 3, let's go ahead and look at the limit as x approaches 1 of 5. And again, this just simply says we're going to come over here to our function, and everywhere there's an x, we're going to put in a 1. Well, if there's nowhere to put an x, then you just get back the function. The limit as x approaches 1 of y equal to 5 is equal to 1, and equal to 5, and this makes sense because if you look at what y equals 5 looks like, it is actually going to be a line that passes through y equals 5. So if we look at this, what happens as we get closer and closer to 1? Whether we are doing this, and by the way that was 5, from the right or the left, we get back 5. Matter of fact, no matter what value of x we approach from the left to right, we always get back 5. And you can see that graphically, but you can also see this analytically. Again, if you just look at your function and try a direct substitution, you're just going to get the answer 5. Okay, in our next example here, let's try the limit as x approaches negative 3 of the quantity x squared minus x plus 4. Okay, again, this involves a direct substitution. We're going to take this function here, and everywhere there is an x, we're going to make it a negative 3. Now, when you're doing this, you may need to do this in baby steps because you're going to go through each thing. So in other words, first thing I have is an x. that is going to be a negative 3 squared. If you're not sure of how to put that negative 3 and put it in parentheses, it will help you to figure out what it is you're going to do later. Then in the formula I have a minus, then I have an x, which will be a negative 3, and then I have a plus 4. And remember that when we square a negative 3 in parentheses, it means we take the whole negative 3 and multiply it times negative 3. Negative 3 times negative 3 is going to be 9. Then we have two negatives together. That makes that a plus 3 plus 4. And I think if you add all these together, you're going to get 16. Again, notice my notation in this. I'm writing out that I'm taking the limit. Math is a language. It tells us what to do. In doing a direct substitution, I use an equal sign to indicate that I'm coming down here to the next line. And then I work my problem using equal signs until I get to my final answer.